A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to the session of climatology, where from today we shall be initiating the discussion about the global climate, about the factors which tend to influence global climate. Because when we talk about climate, climate is one of those factors which influences not only the distribution of population, but also one of the factors which influences how the population lives. For example, the climatic conditions of a region also ends up impacting the amount of rainfall and when is it that a region will receive rainfall. How much dry conditions do prevail in an area. Why is it that the regions such as Rajasthan, they tend to be desertified areas? And why is it that the regions such as the western part of Western Ghats end up receiving very high quantity of rainfall throughout the year? Now, the climatic conditions of a region will also end up influencing the type of vegetation, the trees, the animals, the biodiversity that you find in an area. That, in a way, will impact the food source. That the food source in a region also impacts your dietary habits. And those dietary habits, they lead to various lifestyle changes, etc. So that is why climate is very, very important factor. And UPSC will ask you questions from climatology regardless of the distribution of questions in the prelims and the mains examination. Climatology is going to be one of the favorite areas of UPSC because your understanding of what goes on across the world will automatically and always be dependent upon climatology. For example, if I ask you a simple normal question that you would have heard about the region of Siberia, northern portion and northeastern portion of Siberia. Now, if you compare that to the Indo-Gangetic plains, that is the northern plains of India. Now, as compared to Siberia and the northern part of India, where do you think greater amount of population will reside? Where do you think that the greater amount of people will be living? In Siberia or in northern part of India? What do you think? Very good. Impacted by the variations in climate. Now, from today onwards, we are going to be initiating a discussion for the entirety of the portion of climatology, in which we are going to cover the very details of this portion of climatology, very significant details. Many of the portion you won't be finding in any of the reference books have been taken from various research papers, have been taken from various different meteorological institutions and their findings. So that is why I would request and urge all of you to be as regular as you can be in the case of climatology. Because more than anything else, this climatology and the modules of climatology are going to function in a cascading manner, where one on top of another, we are going to build the concepts. Each of the individual concepts that we are going to study, we are going to assume that we don't know anything about it, other than the factors, let's suppose evaporation, condensation. I assume that that is something that we would be aware of. Conduction, convection, we should be aware of these terms. Now, other than that, each of the terms will be picked right from the bottom. And once we have elevated the level of discussion depending upon your comfort level, that is where we shall be building the superstructure which is required for your better conceptualization of climatology. So the first module of climatology is going to be about the basics and the details of atmosphere, the layers of atmosphere, the structure of atmosphere, the temperature variation as you move from the lower regions of the atmosphere to the upper level. Because for many of us, This idea about how the atmosphere gets warmed up, even that is not very clear. So, this is one of the basic modules, again, where we will be spending some time. After that, the next module that we are going to study is going to be about atmospheric pressure, the wind factors, the wind patterns. After that, the module to the next is where we shall be picking up the strands and the portions from the area of humidity, precipitation, the types of rainfall. Why is it that clouds get created? What are cloudburst, hailstorm events, fog formation? After that, we are going to study about the factors of cyclones, the different types of cyclones, cyclones which influence the Indian coastline, the cyclones which impact the other parts of the world, which parts of the world are impacted by the cyclones. Then we are going to study about slightly complex atmospheric phenomena such as El Nino, La Nina, Walker circulation, Indian Ocean dipole, Madden-Julian oscillation. All of these will help us understand one of the most conceptual portions in climatology, that is Indian monsoon. That portion of Indian geography we are going to cover along with climatology itself. And then we are going to talk about the global climate, world geography, that is the global climatic distribution. But before that, I see many of you have basically been regular, those of you who are present. So, have you gained an overall perspective of the world based on geomorphology? Where fold mountains are there? What are the fold mountains? What are the various earthquakes, volcanoes in various parts of the world? Have you been able to gain an overall perspective about the various different portions of the world? Yes? So I hope none of you hold that kind of grievance. That portion of world geography is not covered separately. We will cover again these portions with the help of mapping modules, and thereby slowly and steadily, when we study about the climate of the world also, oceans of the world also, if you comprehend all of them together, all that I want you to do is be attentive in the sessions and be aware enough to form an interconnection to the previous modules wherever there is a possibility arising out of it. Okay? Just by that interconnectivity, you can gain an advantage which will simply be unparalleled. So, kindly do follow that and be very regular with the portions of climatology. Okay? Lowest basically is Ankush, lowest or lowest plains, just like the glacial till is a deposit carried out by glaciers. Similarly, many of the times the winds, they erode certain amount of rock particles, certain amount of sand particles. They deposit them in the form of a plain-like format, just like the flood plains in the case of the river. They deposit those dried materials in the form of a plain like format, that is the lowest plains. For example, the western part of China, the Xinjiang region of China, is one of the large lowest plains. Okay. Shelja, after attending geomorphology, I realize it is so easy. It is good to know. Just keep on revising those. Please don't let this geomorphology be thing of a past where after 10 classes, if I ask you about diastrophism, suddenly there is a panic which strikes. That is something that you should avoid as long as you keep on revising. And here only I will give you some idea about how to revise. See, we have covered around five modules of geomorphology in very great detail. Let me tell you and assure you, if you are regular and if you have attended the discussions, there won't be a question in the mains examination which will be outside the purview of our discussion. That is something I can give in writing. That is something I can give as a guarantee. So, for example, let's suppose from today we initiate the discussion of climatology. You have again 2 to 3 days gap from Saturday, Sunday, Monday. Do revise the portions of plate tectonics at least. From plate tectonics, automatically earthquake volcanoes will be revised. Right? Landforms, the more times you repeat, and I have provided you with the images, the better you will get at it. Okay? I gave the prelims test series yesterday. I did not get good marks. Don't worry. Again, I would say, I'm not one of those who will tell you, who will hound you why you did not get good marks. I want you to try and I want you to understand where you are committing the mistakes. Okay. So that is something which is good. Lagima book recommendation for geography? No. In the first class itself, I told you. As of now, I am sure you are following many other things together. Just be regular with the portions of PPT, the additional reading materials on a day to day basis. Just revise that. After the sessions are over, maybe you can pick up an NCRT or the pre recorded lectures, tablet lectures that you have had. Just go through them, browse through them, keep on repeating the same thing again and again and again. More than sufficient. Please don't fall into the allure that I have to study GC Leong or Majid Hussain, otherwise my life is done. No. For GS, this much portion, just be regular in this much portion. Ask your competition, your friends, your peers about the conceptual details that we have studied here. You'll find that you have a very good advantage over them. Okay, at least for the examination perspective, right? Now, by the way, again, yesterday I told you that on Saturday we are going to have an extra session. That is something we are not going to hold this Saturday. Many of you had written a mail that you are not comfortable with the extra session this Saturday. Plus, there were some other external issues also. So that is why this Saturday we are going to postpone that extra class. We are going to hold that extra class next Saturday. This Saturday, no extra session for geography. Next Saturday, we are going to hold an extra session for geography. So that means you have Saturday, Sunday, and Monday. 3 days you have got to yourself. You can relax, which is very important. But please do revise also. This Saturday, again, I will repeat, no extra session for geography. Okay. Now, here we start with the portion of atmosphere and temperature. Now, here, this is a chapter, this is a module which is relevant both for your prelims as well as for your mains examination. Questions have been repeated in this area. And as we discuss the PPT, we move ahead. I will tell you from this area exactly what question has been asked. And you will find that verbatim, these kind of discussions have been asked in the examination. So that should give you with some amount of confidence that you are on a right path, provided you are able to relate it with your surroundings. Okay. So in the prelims, you can have questions about layers of atmosphere, layers of atmosphere. Then you can have a question about lapse rate. Then variation in insulation. Variation in temperature across the world, obviously. Temperature. Then after that, you can have a question being asked from the area of temperature inversion. Inversion. You can have a question being framed from the region of, even when we talk about the details of temperature inversion and urban heat islands, but that is mostly for the mains examination where the question has been repeated from this area, right? Here, isothermal variation. In the mains examination, urban heat islands, temperature inversion, factors determining determining the variation in temperature layers of atmosphere. But let me also tell you that it is not as if that, for example, there was a question which was asked that why are all the global climatic phenomena restricted in the region of troposphere, that is the lowest layer of the atmosphere. Now, that kind of a question, your answering ability will develop by the time that you are able to look at the larger picture of climatology. So, have some patience, because I understand many of you immediately after each of the chapters and during the study of these chapters, you pick up the PYQs. So, hold some patience, hold your horses. Trust me, by the end of this climatology and also the initial class of oceanography, where we discuss the impact of oceans on climate, by that point of time, your conceptual clarity will be such greater. You will have the ability to answer any kind of question being framed from this area. I will give you the PYQs from these regions also so that you feel a bit of a comfort level. So that is the portion that we are going to discuss. And that is basically going to be our approach. A very important question, by the way. If I prepare for mains, then prelims can be cleared. The answer is yes. Always your preparation should be mains oriented. Many of you have I have a difficulty in understanding that. Your preparation should always be mains oriented. Prelims is where you will revise the factual portions a couple of months earlier. But if your preparation is only towards the prelims, take it in writing, you will never get through the mains exam. You might get through, succeed in the prelims one year or the next. But if your preparation is mains oriented, maybe you don't, you maybe if one year you might find it difficult to clear the prelims examination. But the moment you clear the prelims examination, mains will be cleared for definite, and then interview. Because once you prepare for the mains examination, you develop the perspective. That is what is required even for the interview. Okay. For prelims, ideally, you have to start focusing on separately on prelims. If the prelims examination is at the end of May, let's suppose, you have to initiate a full focus study of prelims from the month of February. Otherwise, just carry on the preparation of the mains examination, the portions of the mains examination for all the areas. And obviously, current affairs is something that I'm sure you are studying and covering on a daily basis. So that should not pose any difficulty. Okay. Yes, we have the, here you get the opportunity to appear for the mains test series also. Okay. So now we start with the portion of atmosphere. When we talk about atmosphere, atmosphere is a thick blanket of gas which envelops the entirety of the planet. Now, this particular image that I have put here, it is for a purpose I have put this image. Now here, basically, what you are seeing as this lighted portion, that is not the ground surface which is lighted up. That is basically the atmospheric particles, the air particles. So planet Earth is surrounded by a blanket of air. All of us, wherever, in whichever room that you are sitting in right now, wherever you are standing right now, you have a surrounding of the air blanket around you. But we don't feel that air, do we? We don't get to feel that air. That if my hand is moving, that here there is more air, here there is less air. We don't get to feel that, do we? Only when that air tends to move in the form of a wind pattern or in a kind of a breeze do we get to feel that air. This atmosphere, first of all, is not uniform. The air that you breathe in on the ground surface is not the same air that you will find 1,000 kilometers above. This atmosphere starts from the ground surface, extends for thousands of kilometers, but the density of the air keeps on reducing as you move up. Eventually, thousands of kilometers above the ground surface, the air becomes so very scarce, so very limited, that you won't be even able to feel it, and you won't even be able to breathe there. It merges into the outer space eventually. So, the property of these air particles, how they are distributed, their own individual phenomena, that determines the climatic conditions, that determines even the auroras that we have studied. Everything is determined by these air particles. So, let us understand them in detail. But first of all, just like in geomorphology, we had initiated the discussion with the origin of planet Earth. Here also, we will initiate the discussion with the origin of the atmosphere. When we talk about atmosphere, since the time of formation of planet Earth, atmosphere has gone through massive changes. The atmosphere in the initial portions when the planet was still getting created, at that point of time, the atmosphere was very different. When the planet was still getting created, you had the atmosphere which consisted of gases such as hydrogen and helium. Hydrogen and helium. These were the gases which would dominate. Okay, these were the gases which were very predominant at that point of time. Then, slowly and steadily, we have studied that during the evolution of planet Earth, that multiple different gases came into existence. So, what was the stage in the evolution of planet Earth when multiple different gases were injected into the atmosphere? Let me see if we are aware of that. Very good. Vishant, Vishal, Vibhu, Amritansh, Lekhani. Good. Aryan, correct. GIB, correct. So basically, it was in the phase of degasification when you had multiple volcanic eruptions and ruptures happening across the planet. When you had gases such as ammonia. Ammonia is what? Ammonia is NH3, a compound of nitrogen. Gases such as oxygen, sulfur, carbon dioxide, right? Oxygen not in that much amount. Oxygen was still almost negligible. Carbon dioxide, sulfur dioxide, hydrogen, water vapor, methane, all of them were injected. And that is when, for billions of years, planet's atmosphere consisted only of these gases. Nitrates, that is ammonia, then, for example, the various different types of carbon compounds, sulfur compounds, sulfur oxides, carbon oxides, nitrous oxides. These were the dominant ones. Oxygen was still not very much present. It was present, but in very little quantities. Then, this condition prevailed for a long time. Now, carbon dioxide has got a property where it tends to warm the surface because of the fact that it does not allow the heat rays to escape. That is why carbon dioxide has got a warming property. So when the carbon dioxide immediately, its whenever its proportion would increase substantially, the planet would go through a phase of warming. Even today, when you hear about the term global warming, it is always heard in the context of increased injection of carbon dioxide into the atmosphere. Now, the planet Earth in its time of evolution has gone through multiple different phases of freezing, where everything got frozen to death. But again, whenever volcanic eruptions created a surge in carbon dioxide concentration, that is when the planet would warm up. And it was only around a few 100 million years back when large number of plants, they started dominating the surface. And these large number of plants, when they dominated the surface, they started providing oxygen. Why? Because the plants, they carry out the process of photosynthesis. So because they carry out photosynthesis, in the abundance of carbon dioxide, the plants would grow. Large plants would come into existence because they would take in carbon dioxide, provide oxygen. And this blanket of plant cover across the planet successfully increased the oxygen cover. There was a sudden rapid rise in the oxygen levels across the planet. The species which would carry out the process of respiration. Respiration is what? What you and I carry out in the form of breathing. We take in oxygen, we give out carbon dioxide. Now, when the amount of oxygen was very limited, the species were also very small because large bodies could not be supported. Right? Large body functionalism and large body metabolism could not be supported with very little oxygen. The plants dominated, enrich the atmosphere with such huge amount of oxygen in the next few million years. That is when the animals, they started growing larger in size. You had the older arthropods, the form of, for example, the worms that you see today. The older arthropods and the reptiles which could grow for many meters altogether. You had the growth of reptiles, which basically would dominate the land. There was that ensuing battle between reptiles and mammals, in which always the reptiles would dominate. And you had the evolution of some of the largest, many of the largest of the species, which ruled the underwater conditions, under ocean conditions. They don't even exist now. But we have the evidences that at one point of time, the sudden surge in oxygen levels provided the conditions which was ideal for species which were almost 20, 30, 40 times the size of the blue whale. Think about it. Blue whale is the largest species that you see today. The dinosaurs came into existence. So that is how the atmosphere evolved. So when you talk about the evolution of atmosphere, you have to cover the three different phases of evolution of atmosphere. The first, or the initial phases, is what is the primordial atmosphere. When the atmosphere, in the very initial stage, when the planet was still cooling, the planet was not stable, at that point of time, the air or atmosphere consisted of hydrogen and helium. They consisted of hydrogen and helium. Now, these are very light gases, right? So they won't be, or they weren't able to stick significantly with the Earth's surface. Solar winds and solar flares would shave off many of them, because remember, we talked about the fact that around 4 billion years back, 4.5 billion years back, the planet was very unstable. The solar system was very unstable. You had large number of solar winds, etc., which would do the rounds. And much of that helium was shaved away. Some of them remained. Some of that hydrogen remained. But this was the dominant one. Then, when the planet entered into the phase of degasification, that is when new gases came into existence during the phase of degasification. Okay. Now, when we say during the phase of degasification, here, which new gases came into existence? You had ammonia, carbon dioxide, carbon monoxide, sulfur dioxide, hydrogen, water vapor, right? Oxygen was still not dominant here, very trace quantities here and there. Now, understand a basic logic here. All these gases since that point of time, their proportion has increased or decreased. Because if you have a lot of carbon dioxide in the atmosphere, they would be dissolved by the rocks. The rocks would be forming carbonates, right? Calcium carbonate, magnesium carbonate, potassium carbonate, etc. Various minerals in the rocks, they would react with the carbon dioxide in the atmosphere. They would form carbonates over a period of hundreds of years. The sulfur, which would be present, would react to form sulfates. Hydrogen would form hydroxides. But there was one of these gases which did not react very readily, and that was nitrogen. Substantial amount of nitrogen which was introduced into the atmosphere at that point of time continued to be prevalent. And this nitrogen in its natural state is not very reactive. It behaves almost like an inert gas. So while all the other gases, their proportion would increase or decrease, the proportion of nitrogen remained almost consistent. Nitrogen and the quantity of nitrogen remained almost consistent. That is why even today, the most dominant gas in the atmosphere is what? Nitrogen, because it has not reacted. Over that period of time, for millions, hundreds, and millions of years, carbon dioxide's proportion has reduced drastically. Sulfur dioxide's proportion has reduced drastically. Oxygen's proportion has increased. But nitrogen has maintained itself. Now, if the nitrogen is not very reactive, then can we elevate the discussion to the extent where we say that the rocks, the general parent rocks across the globe, the rocks will be poor in nitrogen? Yes or no? Rocks are poor in nitrates as atmospheric nitrogen is not very reactive. Understood? Right? That nitrogen, because that is not very reactive, it won't react with the rocks. So its condition, its proportion will remain almost consistent. Now, if the rocks are poor in nitrate, it is the weathering of these rocks which leads to the formation of soil. Across the world, the soil that is formed is because of weathering of the rocks, isn't it? If the rocks are poor in nitrates, can we say that the soil will be poor in nitrogen? Can we say that the soil will be poor in nitrogen? Yes, correct. So, this is the reason why the soil across the world is very, very poor in nitrogen, even today. We will study it in the portion of even Indian geography, the biogeography portion. Soils across the world are poor in nitrogen, and nitrogen is required for the growth of plants. So that is why nitrogen fertilizer is one of the most important fertilizer that you apply. Urea is one of the most important fertilizer that you apply for the growth of crops, right? So this application of urea into the soil, the necessity of providing artificial supply of nitrogen into the soil, stems from the fact that nitrogen in the air is not very reactive, has remained almost consistent for hundreds of millions of years. Having said that, you had the modification of atmosphere, and this happened when you have the existence of or evolution of plants. evolution of plants and domination of plants basically reduced the concentration of CO2 and increased the concentration oxygen. It is only because of the modification of atmosphere that we have been able to successfully live on the planet. Many different species that have existed, that do exist, they are existing successfully because of that evolution and the modification of atmosphere. Now, from here, UPSC had asked a question, multiple statement question in the prelims, and I will tell you the question statement, and you let me know whether it is correct or whether it is true or false. The statement was that planet's atmosphere consisted of oxygen ever since the time of its formation. True or false? Good. Very good. So it is going to be false. The planet's Earth had the abundance of oxygen, formation of oxygen at a much later stage. It was not always rich in oxygen. Okay, so these kind of twist in multiple statement questions where you have nowadays the pattern only one statement is correct, two statements are correct, three statements are correct. This kind of statements are inserted by UPSC in the portion of evolution of atmosphere. UPSC is not going to ask you in detail. It is not going to mention in the syllabus that study the evolution of atmosphere. That is something which you don't find even in the NCRTs or the reference books. But that is where UPSC tends to twist it up. Okay, I hope we are comfortable. Now we come to the composition of the atmosphere. Now, when we talk about the composition of atmosphere, before that, how many of us are aware about, or rather, how many of us are not aware about what is the greenhouse effect? Are we aware about the greenhouse effect or are we not aware about the greenhouse effect? Not aware? Okay, fair enough. No issues. Now, yes, it was discussed in the previous class, but many of us might not have paid attention there. Okay, fair enough. I'll repeat it. Now, what is the concept of a greenhouse? So, we will basically talk about the fact that in the colder conditions of northern and western Europe, northern portion of America, the conditions during the winter months would be so very harsh, or otherwise also during the nights, the conditions would get so very cold that crop plants could not be supported, they would die of frost. That is when a particular innovation was arrived at where glass houses were built. And these glass houses had the property where these glass houses, they would take in or allow the solar rays to come in, and the heat would be trapped inside, maintaining the temperature, high temperature inside. This would allow for the growth of green plants. And that is the concept from where the term greenhouse was derived from. But why does this phenomena happen? You would have experienced it otherwise also. That let's suppose you roll down or you roll up the windows of your car, or let's suppose in your room, if sunlight comes through the glass windows. Now close the windows. Allow the sunlight to come in. Leave the room. After some time, when you get into the room, maybe when the sunlight has long disappeared, you will still find the room to be very warm. Because while the glass is allowing the heat to come in, it is not allowing the heat to go out. Why is it so? Does only glass carry out this property, or is there a larger fundamental involved? So that is the effect which is known as the greenhouse effect. But here, let us understand the basics first. Now, any object which is hot will emit energy. Any object. You would have seen the older light bulbs, not the modern CFL ones, the older light bulbs, right, which you would have seen in your house. It might be there or somewhere else. Now, the bigger the light bulb, hotter it would get. Closer to you, the bigger light bulbs or the halogen lights you would get, it would get very hot and warm, isn't it? So any hot object would always release energy. Energy is released in the form of waves. Okay, we have seen in the case of seismic waves also. Energy is always released in the form of wave pattern. So let's suppose you have two objects. Let's suppose you have two objects. Here, the temperature is 1000 degrees Celsius. Here, the temperature is 100 degrees Celsius, let's suppose. Now here, if I ask you, if I name this body as A, if I name this body as B, which will emit the energy more frequently? More continuously energy will be released from where? A or B? Easy. A will release more amount of energy. But how will A release more amount of energy? By continuously sending out waves, one after another continuously. Pulses of these waves will be shot out. Whereas in comparison, B will release pulses of energy, but a slightly greater interval. At less frequency, it will send out. So the energy will be released like this, low energy, isn't it? So that is the property of any hot object. It is indicated by various different principles of thermodynamism and thermodynamics, black body radiation, etc., that I'm not going to go into the details of. It is governed by, if you are curious, it is governed by the principle of physics, Stephen Boltzmann law, but will not go into that. Just here, the primary information is sufficient that A, because it has got very high temperature, will continue to emit energy very frequently, quickly. So there will be multiple such small waves, what are referred to as short waves, because the distance or the time interval between each of the wave is very less. So these are your short waves. And then the colder object will release energy with a substantial amount of time interval. And that is what is a long wave. Okay. Now, with that basic effect, here, can we come at our first conclusion? The first conclusion is hot objects release short waves. Short waves means the wavelength is shorter, and colder objects release long waves. Short waves have higher energy. Very high energy. Long waves have very low energy level. very low energy level. Okay, that is the case. Now, sun will release short waves or long waves here because sun is hot. So, sun will release short waves or long waves. Very good. Always short waves because it is very, very hot. So, the sun will release substantial amount of short waves. Now, these short waves, they will fall on the surface of the planet. The planet will start to get heated up, right? The temperature on the ground can lead to 40 degrees, 45 degrees, 50 degrees Celsius. But still, it is much colder than the sun. Sun, where you have the temperature of thousands of degrees Celsius, a 40, 50 degree temperature ground surface is much colder than the sun, isn't it? Now, because this was a short wave, what is the solar shortwave radiation? What is also referred to as the solar shortwave radiation. Shortwave radiation. Its energy level, short waves, energy level is very high. So the energy level of these waves will be very high. So these waves will be able to push through, penetrate to the atmosphere very easily and hit the ground surface. Now the ground surface has started heating up. The ground surface has started warming up. When the ground surface starts to warm up, now it will also start acting as a hot body. Maybe not as hot as the sun, but it will also start acting as a hot object. So now the ground starts to release its own energy in the form of waves. That energy released from the ground is what is terrestrial radiation. So the ground surface will now start to release energy in the form of terrestrial radiation. Now, that terrestrial radiation, is it going to be the short wave or is it going to be the long wave? Very good. It is going to be long waves. Good. Because the ground surface, not very hot, 30, 40, 45 degrees Celsius, maybe 50 degrees Celsius in some places. That's it. So here you will have a long wave terrestrial radiation which is released. Now this long wave terrestrial radiation will be low in energy, isn't it? It will be low in energy. So the gases that you have, gases such as CO2, water vapor, N2O, NO2, methane, sulfur hexafluoride, all these gases which are present in the atmosphere, which are also known as the greenhouse gases, by the way, gases like CO2, methane, etc. Now, these gases, just like the glass would not allow the heat to escape, these gases would hold that low energy wave, low energy terrestrial radiation. Some part of it would still manage to escape into the outer space, but majority of it would be reflected back. They would again heat the planet, then again the planet would release another terrestrial radiation that would again be reflected. So here again, the same work is happening. That a greenhouse, it is taking in the heat, not allowing the heat to escape. So that is the greenhouse effect. So these gases, they allow the shortwave radiation to come in, allow the shortwave radiation to come in. come in, but hold, trap the long wave terrestrial radiation. Okay, now what will it lead to? It will lead to warming, isn't it? So if the proportion of carbon dioxide goes higher up, there will be increased amount of warming across the planet always. So that is how it will always provide substantial amount of warming. Okay, so that is the case of greenhouse effect. Now, is the greenhouse effect good for the planet or is it bad for the planet? What do you think? Okay, you see, moon has also got ice. Mars has also got ice, lot of ice. They don't have liquid water though. Have you ever thought about it? Why? Lot of Martian surface has got huge amount of ice, but they don't have liquid water. The lunar surface has got a lot of ice. It doesn't have liquid water. Because in these areas, during the daytime when the temperature is high, when the sun is shining in some part of the planet, the daytime temperature is high. But during the night time, there is nothing to trap that high temperature. And during the night time, the temperature reduces to minus 100, minus 200 degrees Celsius. That is why when Elon Musk and the entire world is talking about colonizing the Mars, having human habitations in the Mars, their prime objective is what? How would they do it? They would warm the planet. So if you warm the planet, it becomes habitable. The ice starts melting, liquid water is in existence. On our planet, daytime temperature goes to around 30-40 degrees Celsius. Nighttime temperature doesn't reduce to minus 100, minus 180 degrees Celsius, does it? Why? Because of this greenhouse effect. If this greenhouse phenomena would not have been in existence, then higher the daytime temperature and also very low would be the nighttime temperature that we would observe. Habitability would not or could not be expected. So greenhouse effect is good. It is this greenhouse effect which has allowed the growth of plants across the planet. Okay? But then, whenever you have an increased concentration of carbon dioxide or such gases in the atmosphere, the rate of warming suddenly increases. The temperature of the planet continues to rise up. And that is when we refer to it as global warming. Global warming is a discussion, is a phenomena that you would have come across quite significant frequency in the recent times. That global warming is happening, it is bad. It is not the first time that the planet is warming. Just as an example, if I tell you, around 95 to 90 million years back, when the dinosaurs were full in existence, when you had multiple different species in existence, you had such a huge series of volcanic activities across the world. Huge amount of volcanic eruptions, something that world had not witnessed for many millions of years. Such huge amount of volcanic eruptions happened all across the planet. For example, many of the islands of the Caribbean region, the Bermuda region, etc., they got created during that volcanic phase. Even, for example, when we say about the Deccan Trap, the Deccan Plateau, that also volcanic rocks were ejected at that point of time. So huge amount of volcanism was present. The atmosphere was full of carbon dioxide, and that caused a phase of warming. Underwater, the presence of oxygen declined, carbon dioxide dominated. The largest species underwater, they simply went extinct, not to be found anymore. So the planet always goes through this phase of warming and cooling. It is just that we humans, we have accelerated this process as a natural volcanic eruption would do. So that is why whenever nowadays you hear the term greenhouse effect, you hear it in the negative connotation with the terms of global warming. But greenhouse effect is primarily good. The excess of it is what leads to sudden increase in temperature. Okay? Why do greenhouse gases allow solar energy to come to the earth if it can absorb them and reflect? Because here, the solar energy which is coming is having very high energy level. Think about it. If I have this pen, for example, if this pen is moving at a speed of 1400 kilometer per hour or 1400 meter per second, let's suppose, will it be able to puncture my hand? Easily, yes. It will work like a bullet. It will puncture my hand, go through. But if the same pen is coming at a speed of 2 meter per second, let's suppose, will it be able to puncture my hand? No, my hand will be able to block it. Just like that, the incoming solar rays, they come with very high amount of energy levels. So that is why it is able to penetrate through the gases. But the outgoing terrestrial radiation is of low energy levels. That is why these gases are able to hold them. Is that understood? Okay, right. And does it lapse after some time or keeps on reflecting? It keeps on reflecting. It keeps on reflecting. So, greenhouse effect is what? Greenhouse effect is basically the case where you have the various different gases or any material which doesn't allow the long wave radiations to escape, maintaining or trapping the heat inside. That is the greenhouse effect. Then no use of summer solstice or winter solstice. It's all about the greenhouse effect that we are having. Absolutely yes. Absolutely yes. It is the greenhouse effect which is ensuring the habitability on planet Earth. Why greenhouse effect is only observed on Earth and not. So Jupiter also has many of these gases which don't allow the heat to escape. But we don't know what actually exists in the interior of Jupiter, so we don't have much knowledge about that. But for example, Moon doesn't have, the mass is very less, so obviously the air will be very less. It is the presence of gases like carbon dioxide, methane, etc. That is what allows the presence of this property of trapping the heat. If these gases won't be present, then the heat will escape. For example, Venus is very hot. Venus also experiences a lot of volcanic activities. It is very, very hot. Carbon dioxide is there, right? So here, but can Venus become habitable? The problem with Venus is that the surface is not stable. The surface experiences very, very frequent volcanic activities. That is why. And the substantial amount of gas cover keeps on increasing the temperature in Venus. Okay? It will decrease, Shalja. In order to create a habitat for human on moon. So Elon Musk is not talking about creating a habitation on moon. He's talking about creating the habitation on Mars. So on moon, basically, shield of ozone layer. No, ozone layer is a different phenomena altogether. Ozone layer basically protects you from ultraviolet rays of the sun. You can have a protective suit which can protect you from the ultraviolet rays of the sun. Right, you can have a kind of a particular kind of a clothing which can protect you from the ultraviolet rays of the sun. It is the maintenance of the warmer temperature which will allow the liquid water to be in existence. If liquid water is in existence, conditions would be much more stable. Okay, if moon is a part of earth, then moon would also have these gases. Why would the moon have these gases? The evolution of Earth has happened in a very different manner as compared to the evolution of Moon. It is not as if here the planet, don't think about, many of you, when you think about the moon, you think about it just like a human gives a birth to another human. So a property that one human has, the young one will also have the same property. It is not the case with the Earth and the moon. Planet Earth had the own internal mechanism which led to degasification, which led to the various different types of evolution. Moon did not have those. Moon is one-sixth the size of Earth. So the gravitational pull is almost one-sixth the size of, or the gravitational pull of Earth. So it is unable to hold the gases. That is why in Moon, because the gravitational pull is so less, most of the gases have escaped, right? Most of the gases have escaped the system. And as the gases have escaped the system, there's no such heating. Okay? Now, water vapor is also a greenhouse gas. Depletion of ozone layer you will cover in the portion of environment and ecology. Now we come to the composition of the atmosphere. What is the atmosphere composed of? So atmosphere primarily is constituted of three major components: the gases. And when we say the gases, which gases are we talking about? We are talking about nitrogen, oxygen, argon, carbon dioxide, neon, helium. These are the various different gases. Nitrogen is the most predominant of the gases. Around 78% of the atmospheric composition is dominated by nitrogen, followed by oxygen. But this proportion has increased rapidly in the past few 100 million years, right? And the proportion of carbon dioxide has reduced rapidly. So you have nitrogen, oxygen, argon, CO2, neon, helium. That is the case of the distribution of gases. Now, when we talk about the composition of the atmosphere, the gases, they serve various different properties. One of the property is serve as the life support on the planet. The air that you and I are breathing, that is enabled because of the gases which are present here, right? So they will always serve as the life support on the planet. Even the kind of photosynthetic reactions or the photosynthetic processes, they are also supported by the carbon dioxide. Other than that, they help maintain the planet's temperature, help maintain the planet's temperature due to greenhouse effect. Then water vapor. Now, water vapor is largely concentrated in the lowest portion of the atmosphere. Water vapor is not something which is present up till the top of the atmosphere. Most of the water vapor is restricted to the few kilometers from the ground surface only. You won't find that water vapor to be very dominant above. So when you have that water vapor, most of it is dominantly present in the lower portions. And think about it. All the cloud formations, all the rainfall, snowfall, hailstorm, cloudburst, everything is dependent on the water vapor. When you go out somewhere and you feel that the air is very moist, very humid, water vapor. So, water vapor influences the climate beyond proportions. We will study in the next few modules and next few classes how water vapor has got that influence. Rainfall, systems, everything is dependent, fog formation, everything is dependent on water vapor. So, here has got a significant role to play in influencing the climate. Influences the climate significantly. But this is one thing that you have to keep in mind. Majority of the water vapor is restricted only to the regions closer to the ground surface, the lowest layer of atmosphere. And water vapor is not very abundant. Let's suppose water vapor, I hope we are aware, gaseous form of liquid water. Let's suppose by some supernatural ability, you were to convert all that water vapor into liquid water. They would cover the planet Earth with a thickness of only 1 inch. That's it. Not more than that. With a thickness of 1 inch, they would cover the planet Earth. So it is not very abundantly present. But whatever is present is sufficient in terms of the climatic events. Then, other than this, is an important greenhouse gas. It is a very, very important greenhouse gas. So, also maintains the temperature, right? Now, dust particles. Now, if I ask you the same question, will the dust particles be distributed to the top of the atmosphere, or will they also be restricted to the bottom portion of the atmosphere? What does your logic tell you? Will the dust particles be spread to the top, or will they be restricted to the bottom portion? Very good. Bottom portion. So majority of the dust particles also, they remain concentrated to the lower portions, the bottom portions. Now they also play multiple roles. We will study about one of the roles in significantly greater detail when we talk about cloud formation, etc. But here, the dust particles, one of the roles that they play is basically the case where you talk about help in scattering of light. So what is the scattering of light? So basically, let's suppose you have a lot of these dust particles. Let's suppose a lot of these dust particles. Now, when the solar rays come in, they are not impacted by the gaseous particles. That is why the gaseous particles are not heated by primarily by the incoming solar rays so much. So, but these solar rays, they will hit these dust particles, they will get scattered. Much of these or some of that light will be trapped within the dust particles. During the night time is when that light will be visible to us in the form of diffused light. Right? So you would have seen even in the darkest of the nights, when there is no artificial electrical light around you, when the moon is not shining, still you'll be able to figure out, if your eyes get adjusted a bit, you will still be able to figure out that, okay, here you have a tree, or here you have a kind of a building, or some amount of things you'll be able to figure out, right? Even in the darkest of night. How is it possible? Because of that diffused light which becomes apparent during the night time. So that is why they help in scattering the light, and that is where they trap some solar rays allows us to see during the night by diffused light. Okay? That is the case of the dust particles. Other than this, dust particles play another very major role. And what is the other role played by the dust particle? So basically, these dust particles, they form the platform, or they serve as a platform upon which condensation can happen. Right? Because I hope we are aware that condensation of water vapor into liquid water droplets or solid ice particles, that can never happen in thin air. Always condensation will happen or will require a surface. Condensation can never happen without a surface. Okay? So it will always require a surface. So when you see the clouds, clouds are what? Condensed form of water vapor. Now, if let's suppose the dust particles are not present, the clouds won't form. Because even if there is water vapor, they don't find a surface to condense. Right? So that is where the dust particles, they serve as that platform which allows the water to come to it, attracts the water, and forms that condensation nuclei, what is known as the condensation nuclei. Particles in general, the surfaces in general, they are classified into hygroscopic and hygrophobic. Hygroscopic means those kind of surfaces which attract the water. Hygrophobic refers to those kind of surfaces which will always repel water, not allow water to stick to it. So dust particles, they serve as hygroscopic condensation nuclei, which allows the water vapor to condense, form fog, form cloud, etc., and eventually cause rainfall. So they serve as hygroscopic condensation nuclei, allows water vapor to condense on the surface and is responsible for clouds, fog, etc. Okay, so basically, again, I will repeat, condensation, when it happens, condensation in the very basic forms you would have seen. Take a bottle out of refrigerator, keep it outside. I hope that you have observed this in your life till now. Take a bottle of water, uh, basically, which has been kept in refrigerator, keep it outside. After some time, you will find small droplets of water on that bottle. Have you ever wondered where that droplet of water has come from? Where do you think the droplet of water has come from? It is condensation, isn't it? But condensation of what? I hope none of us is under the misconceived notion that it is the water from inside which is penetrating outside. I hope all of us are aware that it is a condensation of water vapor present in the air around the water bottle, which has condensed on the water bottle. That is why when you keep the water vapor, a water bottle here, let's suppose you keep the water bottle on the surface here, after some time, you will observe that small droplets of water, they start dominating on the outside. So if this water vapor has now condensed into liquid water droplets, why couldn't these happen individually out in the air? Because you did not have a surface. So condensation always requires a surface. Dust particles provide that surface. That is why the dust particles in the air that allows for the formation of fog. Dust particles above, they allow for the formation of clouds. This is the reason why whenever there is a volcanic eruption, huge amount of cloud formation, because the dust particles are significantly provided along with a lot of water vapor. Simultaneous condensations keep on happening. Okay, so they serve as hygroscopic. Hygroscopic here refers to any surface which attracts water rather than repelling water. Any surface which attracts water, that is known as hygroscopic. So hygroscopic nuclei. Okay, right? What the dust particles are made up of? Dust particles can be made up of maybe the small, let's suppose even water droplets, sometimes even dust particles. When you talk about, let's suppose, ashes, sometimes let's suppose shavings of a solid body, anything can end up making the dust particles. Okay, which gas is also present in the exosphere? The lightest of them, that is few molecules of hydrogen. But don't think that in exosphere you will have the same proportion of gases that you have, or the same concentration of gases that you have on the ground surface. Near the ground surface, the density of gases is so very high. Near exosphere, maybe one molecule is here, another molecule is 10 kilometers away, another molecule is 2 kilometers away. So the gases are there present just for the namesake. Can it reach the top of atmosphere by excessive pollution? No, because the atmospheric circulation won't allow it to happen. Is this the reason that grasses have small droplets of water or are frozen? Yes, Jyoti, very good. That is the reason why on the solid surfaces during the winter nights in these months, you will observe that dew formation happens, right? Because the condensation happens. So dew formation also, if let's suppose you provide or you keep your vehicle outside, metallic body, lot of dew formation will be there, right? So surface phenomena determines the, that is why you would have come across the artificial rain, the seeding of the cloud, right? You would have heard this in the past few months about artificial rain. What is done in that? In the region around the cloud cover, you basically spray silver iodide. Silver iodide allows rapid condensation to happen. So, very quickly, water vapor changes into ice droplets, larger ice droplets, so that they will start falling on the ground. They will melt by the time they come to the ground surface. They will form liquid water droplets. So, that is the entire concept of artificial rain. Okay, right? Fog versus mist. Wait for some time. We will come to that there after 2 to 3 modules. If there is dust everywhere, then why there is fog only in some places? Because fog is not dependent on dust particles. I mean, dust particles are required, but fog is dependent on temperature requirements. We'll talk about the condensation process in detail. Don't worry. Okay. Now, please answer my question. Okay. What is your question? Are dust particles of two types, hygroscopic and hygrophobic? Surfaces are of two types, hygroscopic and hygrophobic. But please don't have this kind of a demand in the form of a question. I always try to answer as many questions as possible. But from the next time, if I see this, that answer my question immediately, I'm not going to answer that question. So basically, the surfaces are of two types, hygroscopic, hygrophobic. Hygroscopic means the ones which allow. So, hygroscopic attracts or allows water to stay on that. And then you have hygrophobic, which repels water. You would have had seen the ads for the various tiles or the surfaces that it doesn't allow, it is a water repellent tile, right? How does it do so? Is it because there is some supernatural power that magically this tile is found in the hearts of Mount Doom, from where in the fires of Mordor, where they don't allow the water to come out? No, it is basically the hygrophobic nature of the surface. Okay, dew formation is from this phenomena. Yes. Does it mean that dust particles are present in a cooler place which attracts water vapors to form a base? Higher up that you go, always the temperature is low. So dust particles at an elevation of 3 kilometers, 4 kilometers, 5 kilometers will always be very, very cold. Achal, is that understood? Anjan, is that understood? Dew, dew, cloud formation, fog formation, mist formation, condensation, everything we will study later on. Don't worry. Okay. Hygroscopic allows the water to come to it. Hygrophobic is repellent of water. Phobic. You would have heard about the term phobia. Phobic means what? Something which repels. So phobic will repel water. Scopic will attract water. Okay? Right? Now, after this, we come to the heating of the atmosphere. What are the reasons responsible for fog? Again, I would say very humbly. So, okay, let me do one thing. I will tell you about how we will cover this. Otherwise, see, first we will cover atmosphere and temperature. In this module, we will cover, this is the module in the initial portion about temperature, heating and cooling, basics of heating and cooling we'll cover here. Then we will talk about pressure. In the next module, pressure and wind movement, permanent wind system, local wind systems, etc. Then in the next one, we will talk about humidity and precipitation, where we'll talk about fog formation, mist formation, rainfall, cloud formation, hailstorm, lightning, thunder, cloud burst, specific humidity, absolute humidity. Here you will study about those in detail. Why fog formation, types of fog formation, what is a steam fog, what is a radiation fog, what is an upslope fog, all that, valley fog. Then after that, we will cover the portion of air masses and cyclone, where we'll cover about the frontal formation. We will talk about the temperate tropical cyclones, the type of rainfall caused. Then we will talk about ENSO cycles, ENSO, Indian Ocean Dipole, Madden-Julian oscillation, jet streams. Then we will talk about Indian monsoon. And then we will talk about global climate. Is that understood now? There is a reason why I have distributed the pattern in such a way. Please understand, there's a reason why I have, otherwise I would have started with the Indian monsoon and then covered the rest of them later. There's a reason why I'm doing this, because one by one, step by step, let us move ahead. Just be comfortable with the portions that we are talking about. Move ahead. Everything will be clarified. Okay. CO2 content is very less in atmosphere. Does it need to be even more less for global warming? No. The rate at which the concentration is increasing, Karthik Raj, that is the rate which is damaging the atmosphere. New technique in which silver iodide is used for rain, is it not? Shelja, I had already told you, I have already repeated. Garima, you also had the same question. Hygroscopic allows the water droplets to form on it. Hygrophobic repels the water droplets, doesn't allow the. Okay. Do one thing. Forget that we have discussed the term hygroscopic or hygrophobic. Just remember, water vapor, They serve as condensation nuclei. Is that comfortable for everybody now? Is that comfortable for everybody? Any doubts up till this portion? No doubt? It is hygroscopic. It is G. Hygroscopic. It is not hydroscopic. I had not done a spelling error here. Please have some faith. It is hygroscopic. Okay. Now, how is it that the atmosphere gets heated? The atmosphere is not heated primarily from the incoming solar rays. No. The atmosphere basically is heated from the ground surface upwards. Basically, what happens is that the solar rays, they will hit, the solar rays will basically hit the ground surface by the process of solar radiation. The incoming solar rays, the shortwave solar radiation, very high in energy. Maybe in between, they will impact the topmost portion of atmosphere. They will be able to impact that. But the lower portion is not impacted significantly by these solar waves, right? So the solar waves, they will hit the ground surface. Now, here, in fact, do one thing, understand the basic of it. If you have one which is gaseous molecules, and there's a surface, solid. Gaseous molecules, they will consistently be in motion, isn't it? Gaseous molecules are consistently in motion. Now, if there is heat which is provided here, and if there is the same amount of heat which is provided here, let's name this A, let's name this B. In which of the cases the temperature will rise up faster, not higher or lower, faster? Which will get heated faster, A or B? Always B. Why? Because here, as the rays, the heat will come here. Let's suppose the heat energy will come here. The gases, they can escape easily. They are always in a state of motion. But here the solid is not in a state of motion. The solid is static. The solid is fixed. The molecules are close to each other. Very good. So that heat will be retained. So always, because of this phenomena, the incoming solar rays, they don't impact that much heating of the gases. But the ground surface gets heated up. Now, once the ground surface gets heated up, its temperature rises. Here, temperature rises. Now, as the temperature rises, what will happen? Let's suppose this is the ground surface. Now here, the temperature due to heat has risen up. Now, as the temperature has risen up here, you will have particles, gaseous particles, which are connected, attached. Now, because these gaseous particles are attached to the ground surface, they will get heated up also by the process of conduction, isn't it? So the process of conduction will give heat to the lowest portion of the gases here. Otherwise, also, the earlier experiments that we had talked about heating of water in a kind of a utensil, I hope you remember those. Or if not, I hope you can visualize this. Now, when you heat water or boil water in a utensil, Right. Let's suppose. Let's suppose you boil water in a utensil. Now, in this case, what will happen? Initially, the water in this region will get heated up. Water in the lowest portion gets heated up first. Why? Because it is in contact with the hot utensil, and that hot utensil is getting the source of fire. Right? It is not as if water here will get heated up. No. It is not as if water here will get heated up first. No. First, the water at the bottom will get heated up. Why? Because it is in direct contact. Right? So, like that, when you have a kind of a utensil, or similarly in the case of atmosphere also, the ground surface, as soon as it gets heated up, the ground surface will transmit that heat, right? And that heat will heat up the lowest portion of the atmosphere. Now, once that water surface gets heated up, the lowest portion of water, when it gets heated up, what happens? Convection current, that heat is distributed to the top portion by the process of convection currents. We have seen that. We have studied about the convection currents also, that the lowest portion gets heated up, that heat gets transmitted all around. So here also, in the case of air also, when the lowest portion of the atmosphere will get heated up due to conduction. So see, the ground heats the air by the process of conduction. Once that air, the lowest portion of air gets heated up, then that will rise by the process of convection. And that rise due to the process of convection can lead to the formation of cloud surfaces, or eventually that convection will distribute heat into the upper portions. So here can we write this, that method of heating. We are talking about the lowest layers of atmosphere as of now. Method of heating. Ground surface gains heat due to radiation. Then after that, the heat is transmitted into air by conduction. The heat is distributed by the process of convection. Okay, that is the mode of heating, and the processes in the lowest layers of the atmosphere, mind you. Now, after this, you have another method of the distribution of heat, transfer of heat from one region to another, and that is the process of advection. What is this advection? Conduction, convection, radiation, you would have heard from your childhood days. Advection is not something that you would have heard about frequently. What is this advection? So, recall from your own experience. It is winter month right now. But then, sometimes it might have happened with you also, that a warmer wind or a warmer breeze comes and then moderates the climate, makes the climate more pleasant. During the summer months, recall, a cold wind starts moving and the climate becomes much more pleasant. The temperature becomes cooler or colder. Right? So, what is happening? You have a horizontal movement. The wind is nothing but the horizontal movement of air that we experience. So, when you have colder winds coming into a warmer region, it will cool down that warmer region. When you have warm wind moving into a colder area, it will warm up that region. So that is also a method of distribution of heat, of transfer and distribution of heat. So that is what is referred to as advection. So transfer of heat through horizontal movement of air is called advection across the different parts of the planet. Advection plays a very important role in distributing and maintaining the temperature. When you have cold winds coming from the region of the Arctic, it creates freezing conditions, sub zero conditions in the regions of North America and Europe. Everything gets frozen up. Sometimes during the summer months, you would have in the northern portion of India very warm winds which blow in the name of Lu. Now that substantially increases the temperature. So that is how advection becomes an important factor in distribution of temperature. So advection is broadly of two types. Either the cold winds will come and cool down a surface or region, or the warm winds will come and will heat up a region. So it is of two types. It is of cold advection, warm advection. Okay, so it is of basically two types, cold advection and warm advection. Cold advection is what? So cold advection is the process in which the winds, they blow from a region of cold air to a region of warmer air, which results in cooling of the warmer region. Okay, so cold air will warm up an area. Cold air basically will cool down a region, right? Then warm advection, warm air is coming to a colder region, will warm up a area. It is the process in which the wind blows from a region of warm air to a region of cold air. Example Lu here. Example Lu. Here you can have multiple examples, polar winds, polar winds. You have many local winds. I'll give you the example of these as we move ahead into the next module. You will basically have many of these examples associated thereby also. Okay, so that is the case of the cold and the warm advection. Now we will come to the portion of lapse rate, but before that, we'll take the break. Where do the advection processes initiate? In that is determined by pressure conditions, high pressure to low pressure. We will cover, don't worry. So we take a break and we'll be back in by 7 today. Okay, break till 7 p.m. Be back by 7 p.m. confirmation about the audio, please. Thank you. Now, we'll come to the portion of lapse rate. Now, what is lapse rate? So basically, before coming to the lapse rate, a basic thing that we will concentrate upon, that is the density of air. Air in atmosphere. So, when we talk about the planet Earth, basically, planet Earth is surrounded by atmosphere, a blanket of air, that is the atmosphere. This is your atmosphere. And this is your surface. Now, the maximum density of air will be observed in which portion? So, the air's maximum density will be observed closer to the ground surface. This is where the density will be maximum. And slowly and steadily, the higher you go, the density of air reduces. Why is that the case, and what is the implication of it? Why do you think that is the case? Very good. So, most of you are correct in this. Here, the correct answer is that the density of air is maximum closest to the surface because of the force of gravity. As you move away from the surface, that force of gravity tends to reduce. And that is where the density of air will also reduce. So here, density of air is maximum closest to the ground surface. Due to the force of gravity. As one moves higher up, concentration of air particles reduces. Now, the implication of it. We have seen earlier that for the air, what is the source of heat? So, the ground surface will convey that heat, and that heat will be retained maximum closest to the ground surface. As you move, let's suppose, higher up, the heat supplied will reduce always, isn't it? So that is why here greater number of particles, or first of all, implications of this. Regions of atmosphere closest to the surface will be the warmest, okay, regions of atmosphere closest to the surface, they will be the warmest. Why? Because that is where they are closest to the source of heat. In this case, it is the ground surface. Upon heating up, that ground surface conveys the heat upwards, right? So that is because the regions or the ground surface heats the air from below. Okay, so higher up that you go, that heat will be lesser, isn't it? So that means the implication is that higher that you go, at greater elevations, heat received would reduce, right? Now, the other factor is that if you have greater number of particles closer to the ground surface, if you have greater number of particles closer to the ground surface, let's suppose, now these particles would trap and retain heat amongst themselves. They will not allow the heat to escape. But higher up, the particle density is less, so the heat can escape very easily. I hope we can comprehend that fact, isn't it? So, greater concentration of particles means greater retention of heat. That means a slightly higher temperature. When you have lesser number of particles, means heat can escape easily. So, that means a lower temperature. So, greater concentration of particles would mean a greater retention of heat, right? Lesser concentration of particles allows the heat to escape. To escape. Now, greater retention of heat means what? A higher temperature. So this is indicative. This will be indicative of a higher temperature. Lesser concentration of particles would mean what? Or lesser, or if the heat escapes easily means what? Lower temperature. So that basically means that from the surface, as you move upwards, the temperature tends to reduce always. Now, this variation in temperature, it can happen in either ways. That is indicative of the change. That is why when you go to the top of the mountain, Mount Everest, for example, or the Himalayas, for example, it is very, very cold, sub-zero temperature, right? -10, -15 degrees Celsius. Why? Why is the temperature so low? Because of height. If ever you fly in an airplane, sometimes the airplanes, they show that what is the temperature outside as they are flying. You'll find that at their greatest of the heights, they fly into a region where the temperature is -40, -50 degrees Celsius outside. So basically what you come across is the fact that the temperature in general tends to vary from the ground surface as you move upwards. So that rate of change of temperature from one level to another as you go, that is what is known as lapse rate. So lapse rate is the rate of change of temperature as one moves higher up in the atmosphere. Now, in various areas of atmosphere, it is not always going to be the case that the temperature will only reduce. Sometimes the temperature can increase also in certain cases. For example, when you reach the level of thermosphere and exosphere, that is the outer limit of atmosphere, there you get a complete unadulterated rays of the sun, including X-rays, ultraviolet rays, all of them. So there each of the particles will be bombarded with the solar rays. So there each of the particles will indicate very high temperature, right? But then in the region of troposphere, you will have a different phenomena. So there is a variation in temperature with the variation in altitude. And that is what is regarded as lapse rate. So lapse rate is of three types. One is the positive lapse rate. Positive lapse rate. Another is negative lapse rate. And there is also another one which is known as the zero lapse rate. What are these? So positive lapse rate indicates a reduction in temperature with height. Okay. So temperature reduces with height. Negative lapse rate indicates an increase in temperature with height. And then you also have what is known as a zero lapse rate, means no change in temperature with height. Temperature with height. Now, when is it that the zero or negative lapse rate occurs? Why does it occur? We will cover that. Don't worry. In this module itself, we will cover that in detail. We'll cover the concept of temperature inversion also, etc. So you will get that information. But as of now, we focus on the case of positive lapse rate. So we see that as you move higher up from the surface, as you move higher up from the ground surface, the concentration of air particles, the air molecules, they reduce. And as that concentration reduces, that basically brings into existence a lesser rate of warming also. So, in general, particularly in the lowest layer of the atmosphere, the temperature is highest near the ground surface and decreases as you move higher up. Now, on an average, that variation in altitude leads to a reduction of temperature by around 6.5 degrees Celsius per kilometer. That is, if you move higher by around 1 kilometer, the temperature in general, will reduce by around 6.5 degrees Celsius on an average. So, on an average, in troposphere, that is the lowest layer of the atmosphere, on an average, temperature reduces with height at rate of 6.5 degrees Celsius per kilometer. Okay, so what does that mean? So basically, if you are on the ground surface, let's suppose the ground surface represents 33 degrees Celsius. So if you move by a height of around 2 kilometers, what will be the temperature at the height of 2 kilometers? Very good. The geniuses of maths. Take your time. In a parallel universe, what is the question? The question is, if the ground surface has got a temperature of 33 degrees Celsius and there is a positive lapse rate, so at a height of 2 kilometer, what will be the temperature? 13 degrees Celsius. Okay. 21 degrees Celsius. Okay. It will be 20 degrees Celsius. Don't make me solve this maths. 6.5 degrees Celsius per kilometer into 2. So at a height of 2 kilometer, it will be a reduction by 13 degrees Celsius. Ground surface was 33. Reduction by 13 means at an elevation, it will be 20 degrees Celsius. Right. Again, I will remind you, you have to clear the CSAT examination. Before you even think of clearing the civil services examination, you will have to clear the CSAT paper. Okay. And this is very simple maths. Anyways, so that is the case of positive lapse rate. But you have to understand one thing. And the thing is that it is not always going to be the scenario that the temperature will reduce by the same extent. So here, environmental lapse rate, it is the rate at which the temperature changes with an increase or a decrease in altitude. It is the vertical distribution of temperature. If the lapse rate is positive, the temperature reduces with height, as it usually does. If it is negative, the temperature increases in height, what is also known as temperature inversion. Now, okay, before again, I forget, a reminder that this Saturday we are not going to have an extra class for geography. We are going to have an extra class next Saturday, not this Saturday. So you have the 3 days time with you. 30, 31st, and 1st, you have the 3 days holidays from the weekday classes. So this Saturday, you don't have an extra class for geography. Okay. Now, here, as I told you, it is not always going to be the case that the temperature will reduce at the same rate. Why? Let's suppose in a region, in an area, let's suppose. Yes, first is also a holiday. Now, let's consider two different places. Let's consider a region where water vapor is very high in quantity. Over the oceans generally, or over the coastal areas, water vapor quantity will be very high in general. Right? Let's suppose we consider this as the region of Goa, coastal area. Let's consider another place, that is, let's say, Chandigarh. Chandigarh, drier area, not much amount of a moisture, or better than Chandigarh, let me take an example that everybody will identify with. Jaisalmer. Desert area, water vapor will be very less. Let's suppose here you have dry air. Dry air means minimal water vapor. Okay. Here you have dry air. Now, water vapor, will it retain heat or will it allow the heat to escape? Based upon our previous conversations, water vapor, will it be retaining heat or will it allow the heat to escape? Very good. It will carry out the retention of heat. That is why we have seen that water vapor acts as a greenhouse gas also. It retains heat. So, when the ground surface is releasing or discharging the heat, that heat will be retained by the water particles, water vapor particles rather, within themselves. Isn't it? Whereas, when you have lack of water vapor in the region of Jaisalmer, will that retain heat in this area or will it allow the heat to escape because you don't have water vapor? What do you think will happen here? Will it retain heat or will it allow the heat to escape? Escape, loss of heat. So if I ask you a question that at an elevation of, let's suppose, 3 kilometers, let's suppose, elevation of 3 kilometers, let's suppose the temperature on the ground surface in both the cases is 35 degrees Celsius. At an elevation of 3 kilometers, which will be warmer, Goa or Jaisalmer? Which will be warmer? Beautiful. Very nice. Goa. Why? Because there is so much amount of water vapor, it will start to retain heat. It will not allow the heat to escape. Whereas when the air is dry, the heat escapes very easily. Right? So heat is not retained. So here what do you see is at this height, let's name this as A and let's name this B. temperature at A will be much greater than temperature at B due to retention of heat. Beautiful, guys. Heat by vapor, right? So that tells you that if the air is moist, if the air is humid, loss of heat will happen at a lesser degree. Loss of heat will happen at a lower pace. But if the air is dry, it will immediately start to lose heat very, very quickly. So, various different regions will have different amount of water vapor. For example, coastal areas will have very high amount of water vapor. Oceanic regions will have very high amount of water vapor. But Delhi, Chandigarh, Ambala, Amritsar, all Jaisalmer, Bikaner, these areas will have very little amount of water vapor, isn't it? So that lapse rate is again what? If you take a look at the definition of lapse rate, rate of change of temperature with altitude. So lapse rate will be varying over moist areas as compared to drier areas. So that brings into equation what is known as moist lapse rate. When the air is very, very humid, very moist, right? Moist lapse rate. Generally, temperature reduces at a rate of 5 degrees Celsius per kilometer. That is the case of the moist lapse rate. Whereas in dry conditions, the loss of heat is accelerated. So dry lapse rate happens as the temperature reduces at a rate of 10 degrees Celsius per kilometer. This is the reason why during the rainy season, you will observe that the nights are generally warmer. Always you will hear about the term that cloudy nights are warmer as compared to the clear skied nights. Even those of you, particularly living in the northern portion of the country, you would observe that when there is clear sky, in the night it becomes colder. When it is cloudy, it will be slightly warmer. If it has, let's suppose there has not been much cloud during the daytime and the region has received heat and then it has become cloudy, it will be a bit warmer. This is also the reason why the deserts, they become very hot during the day, but they become very, very cold during the night. Most of the desert species of animals, you'll find that they have a coating of fur in order to adapt to the very cold conditions during the night because it becomes very dry. And that dryness means the loss of heat happens very quickly. In the coastal areas, go to Goa, go to Mumbai, go to Kolkata, go to Chennai. If the daytime temperature is 35 degrees Celsius, nighttime temperature will be 31 degrees Celsius. That's it. If you go to Jaisalmer, Udaipur, Delhi, etc., daytime temperature is 35 degrees Celsius, nighttime temperature will be 22, 21 degrees Celsius. So dry conditions means less retention of heat. Moist conditions means greater retention of heat. So it varies. That lapse rate varies from one region to another. And that basically is going to be the case where you will observe that the temperature variation from one area to another is dependent on many of the factors. Okay. Jaisalmer is more hot than Goa. And water vapor trap heat, which is more in Goa. True. Okay, what is it that is not understood here? So, how it happens? I have told that if the temperature, okay, it is the problem with the example here. If I take the case Delhi, because when you think of a desert, immediately, because we have grown up watching so many movies, that when we think of deserts, we think that, oh my God, it is going to be so very hot, everybody is going to die there. I hope you are aware that there are cold deserts in the world also, right, where the temperature is very, very low. But even, for example, during the winter months, one of the first areas in northern India which experiences 1 degree Celsius, 2 degree Celsius temperature is Churu in Rajasthan. So Churu in Rajasthan gets very, very cold in winter. So always understand that the presence of moisture allows the retention of heat. It retains heat. Achal, is that understood? If I take the example of Delhi in case of Jaisalmer, is that understood or is your problem exaggerated now? Why deserts are hot during the daytime? Because of varying factors, lack of rainfall, then continuous heating. The land gains heat very easily, very quickly. That is why. Okay, what is not understood here? The entire concept. Okay, understand. What is lapse rate? Forget Jaisalmer, forget Goa, forget Delhi. What is lapse rate? Lapse rate is the rate at which the temperature changes as you move higher up. In the region closest to the ground surface, that is the troposphere, if the ground surface is at 40 degrees Celsius, slightly higher up, it will be cooler, maybe 30 degrees Celsius. Slightly higher up, it will be much more cooler. So here, temperature might be 24 degrees Celsius. Ground surface temperature is still 40 degrees Celsius. I'm talking about an elevation of 3 kilometers, 4 kilometers. Let's suppose I'm talking about an elevation of 4 kilometers here. And I hope we are clear with the fact, and we don't have that doubt, that if a region is hot on the ground, right up till the top of the atmosphere, that will be hot. That temperature that you experience, that Jaisalmer is hot or Sahara Desert is a hot region, that is the experience only near the ground surface. If you go at an elevation of 4 kilometers, 5 kilometers, the temperature in a certain cases can reduce to 0 degree and sub-zero degree also. Okay, many of you might not be aware with that, so listen to this carefully. Lapse rate means the temperature reduces with elevation. In drier regions, let's suppose the temperature is 40 degrees Celsius, lapse rate is at 10 degrees per kilometer. So at an elevation of 5 kilometers from the ground surface, what will be the temperature? It will be minus 10 degrees Celsius. Okay. So please don't confuse that on the ground surface it is hot, so always above it also it will be hot. That is not the case. It varies. So there I come to the concept that if you have the presence of moisture or if you have the dry air, then the temperature at these elevations, they will be varying. It will not be consistent. The ground surface temperature is dependent on different factors. I'm talking about the temperature of the atmosphere. I'm not talking about the temperature of the ground surface. I'm talking about the temperature of the atmosphere. So here, is that understood now? Right? Any doubts in this? Yes, Ankush, please go ahead. The coastal regions, the temperature changes from day to night is minimal compared to the non-coastal areas due to water vapor content. Absolutely, yes. Anjan, very good. That is the reason why in the coastal areas the temperature remains largely consistent. Daytime, nighttime temperature variation is not so much. Summer, winter temperature variation is not so much because the water vapor in the atmosphere retains the heat. It doesn't allow the heat to escape. Whereas if you talk about, let's suppose, the region of Punjab, the region of Haryana, the region of Uttar Pradesh, the region of Delhi, the daytime temperature can be very hot due to heating, but because there is no moisture, all that heat escapes from the ground surface. So nighttime temperature will be very, very cold. Okay. Sushmit, when the sun radiation, when the sun radiation hit atmosphere, majorly it's not heated because atmosphere doesn't have the ability to absorb. Yes, Sushmit, perfect. GIB, deserts are having colder nights because of drier air. Drier air is a better wording for that. Prerna will come to that. Ankush, we all know that boiling point of water is nearly 100 degrees Celsius. So when it goes upward, how can it form cloud? It should precipitate before the cloud formation. What is a cloud? What is a cloud? Cloud is basically condensed form of water vapor. Water vapor can get, when it cools down, it changes into liquid water droplets. If it cools down further, water vapor, let's suppose, encounters a temperature of -2 degrees Celsius, directly it will get converted into ice particles. So the cloud is made up of those liquid water droplets and the ice particles. When they become heavier, they bring rainfall. Okay. Yes, Lakshmi, clouds have charge. Now, then we come to the adiabatic process of heating and cooling. So till now, what we have seen is the fact that air is getting heated up or is getting cooled down because of the influence of, let's suppose, the source of heat from the surface, etc. The surface is getting heated up, the air is getting heated up, right? The air is rising up, etc. That is leading to heating or cooling. But sometimes the air tends to gain or lose heat just by the change in its volume. The air tends to gain or lose heat just by the virtue of change in volume. That is the adiabatic process of heating. I will elaborate upon it. So, just as an example, in your childhood days, you would have seen a kind of a air pump. The air pump with which you pump the air into your bicycle tires, unless and until you were born and brought up in a kind of a situation where you would simply call someone who would take your bicycles, get that air filled, and then bring the bicycles to you. If you have not been brought up in those conditions, if you have, let's suppose, actually gone to the mechanic and bicycle repair guy and yourself filled up the air in the bicycles, you would have seen that as repeated movements of the air pumps would happen, the air pump would get heated up after some point of time. Why would that happen? Because of compression of air. So basically, when there is a change in volume of air, there is a heat gained or heat lost. So heat can be gained or lost because of simple virtue of change in the volume of air also. So here, why does that happen and what is it that I'm talking about? So basically, let's suppose we have the air particle or any sample of air, any volume of air. Now this will have various different particles, gaseous particles, maybe water vapor particles. Now these particles would be in motion consistently. These would be in motion. Right? Consistently, these particles would be in motion. Now, by some event or another, let's suppose I manage to compress the air. So all these particles would now be restricted to this small space. All these particles will now be restricted to this small space. Now, each of these will have their motions. Can we say that the amount of collisions that they would have witnessed earlier, that amount of collision would increase drastically? Can we say that these will collide more frequently with each other now as compared to the earlier scenario? Now, collision produces heat. Can we agree to that? That collision produces heat. Now, as compared to this position A, compare it to B, which will have more energy, A or B? Which will have more energy? Very good. B will have more energy here, isn't it? So here, there will be more energy, energy in the form of heat, more energy. More heat. More heat means what? Higher temperature. Comfortable up till here? Right? So by compression of air, when you compress the air, when you compress the air, can we say that the amount of heat, amount of energy, because there will be more collisions now, the amount of energy has increased in that air sample or air parcel? So there will be a higher temperature. Now, let's do the opposite of it. Let's expand the air from the earlier scenario. Now, as you expand the air, the same particles would find greater space. Right? If, let's suppose, we talk about the movement, now the number of collisions that these particles will have, the number of collisions that these particles will that increase or decrease? Number of collisions will decrease, isn't it? So if I talk about in comparison to A, due to expansion, here what has happened? There has been an expansion of air. Due to expansion, can we say that the amount of energy will be less, lesser collision, lesser number of collisions, lesser friction also generated, correct? So as a result, can we say that there will be lesser energy? Less energy means, can we indicate it with a lower temperature? So can we come to the conclusion here that from the earlier scenario, the air temperature has changed just by the virtue of expansion and compression of air? When the air has expanded, basically it has cooled down. When the air has been compressed, it has heated up. Can we think about a scenario like this? This is what is also known as adiabatic heating. Adiabatic heating. And this other one is what is known as adiabatic cooling. Now, you might have a question in your mind that where does this happen? Why are you saying that the air volume will change? It will expand, it will compress. So it happens in various different areas. Just to give you an example, let's suppose you have a mountainous region or a hilly area. Now, here also, many of them have a very wrong conception about the movement of air. So I will try to correct that as well. Yes, GIB, that is correct. So here also, I will give you two pathways of air. Tell me which is the plausible pathway for the air movement. So one pathway I will give is the air comes, faces the mountain, and this is, let's suppose, the pathway number one. Pathway number two is so which is the more apt pathway that the air will follow? This is why it was important to ask this question. So, how many of us, that means many of us, we have a belief that the wind can use the mountain as a launch pad to launch into outer space, right? We can conclude if all of us who are saying that the pathway number one is more plausible, can we think of a scenario in that case that as the wind comes, eventually from the top of the mountain, it will keep on getting lifted like an airplane and it will escape into the outer space? Can we think of a scenario like this? That it will start taking off? There is something which is known as gravity. Gravity is ever so persistent around us. Anything which goes up has to come down. So the pathway for the wind is never going to be that of a launch pad, that the wind is coming and it gets lifted up. In that ways, all the winds hitting the Himalayas would have launched into outer space, right? So why would the winds come down in that case ever? So that is never going to be the case. Sorry to disappoint your imagination and the kind of imagery that you would have had of the wind. So that is not the case. This is the pathway followed by the wind. Whatever goes up, it will come down. Why? It is not based on me. If my wish would have been followed, then all the air would never have risen up. If it would have risen up, we would have taken it to Jupiter altogether. But it is because of gravity where everything has to eventually come down. So here, when the wind faces this mountain, basically, it will start rising up here. It will start rising up here. Now, again, let's name this height as A. Let's name this height as B. Density of air will be lesser where? A or B? Very good. Density of air will be lesser at B. That means at the region of B, there will be lesser number of particles around. A lot of particles filled in that place. So remember your experience when you basically climb up to in a crowded train or a crowded bus where it is a lot of crowd, lot of people standing around. You compress yourself. You try to minimize your own volume and surface area to the best of the possible manner that you can. But then you enter into the empty coach of a metro train or an empty bus. What do? Immediately you stretch yourself. Immediately the legs go out, right? On the next seat also you put up your legs, you almost lie down, you chill out. So what does that tell you? That when the crowding is less, you tend to expand yourself. Not that your volume can increase, but then you try to expand yourself. When it is significantly crowded, you tend to crouch, you tend to compress yourself. Fair enough. So as the air here rises up, can we say that the air is going to the region of lesser air density? So it will expand. Can we say that it will expand? So expansion will lead to cooling. Expansion will always lead to cooling. So by the time that the air reaches the top of the mountain, can we have a scenario where the temperature will reduce? Temperature falls, right? Comfortable? Srilata, are we comfortable up till here? Okay. Now, Ashish, that is why I'm giving you this example. That as the air moves higher up, listen to this example. Get rid of all the preconceived notions that you have about the thermodynamic setup, that it will move heat here or there, etc. Get rid of all those mental reservations. Think about only this example. The air is rising up the mountain. As the air is rising up the mountain, can we think about a scenario that air is coming to the region of lesser density, so it will tend to expand? Are we comfortable with this? So when the air expands, energy level for the number of particles, the energy level will be low. So when the energy level will be low, that means energy is what? Heat is form of energy. That means it will be cooler. Now, conversely, let's suppose the air comes down. It starts falling down. Now, as it starts falling down, can we say that the air is going into the region of very crowded region where there's a lot of air density around? So what does the air do? This falling air parcel, it will have to compress itself to accommodate in that area, right? It will have to compress itself to accommodate in that area. Now, here also some of you might have a question that if it is already so crowded, why will the air go there? Better find some other place for itself. But again, the same elephant in the room, that is gravity. Gravity will pull it down. So here, as the air comes down into a more compressed area or a more denser area, it will compress itself. So there is expansion in this region. Can we say there will be compression in this area? Comfortable with this? Compression of air. Ashish, Srilata, let me know. Are we comfortable with this? That as the air comes down here, it is coming into a very crowded and dense area. So there will be compression, right? So when there is compression, means the same air parcel has reduced in size. The particles will collide with each other more friction, more energy generated, more heat. So there is heating of air. Heating of air. But this cooling and heating of air has not happened because there is a source of heat provided or a colder surface in contact. This heating or cooling of air has happened purely by virtue of its change in volume. That change in volume leading to a change in temperature of the air parcel, that is what is adiabatic heating and adiabatic cooling. Okay? So here, when air, so adiabatic cooling, when air is forced to rise up in the atmosphere, even let's suppose by convection, due to the convection process, the air is rising up. There also, it will go into the region of lesser air density, so it will always tend to expand, right? So the air density and pressure reduces with height. As the parcel of air will expand, in the case of lower density and lower pressure, its temperature will fall due to fewer molecular collisions in the larger volume. Therefore, we observe a decrease in temperature due to expansion. That is adiabatic expansion or adiabatic cooling, rather. Okay. The converse of it is adiabatic heating, which happens when a cooler, less dense air that sinks and exhibits an increase in temperature. Why does that happen? Due to the molecules being forced to a region of higher air density. Due to this, the molecules, they start becoming agitated, start vibrating, and indicate an increase in temperature, indicate an increase in heat. Okay, that is the case of adiabatic heating, adiabatic cooling. Okay, no heat is exchanged from the surrounding areas. No, that eventual hotter air will heat up the surrounding regions. Will basically, for example, we'll study in the next module. For example, in the Rocky Mountains, on the eastern slope of the Rocky Mountains, you have this falling air, which is warm enough to melt the snow in that area. That is the wind which is known as Chinook, which is also referred to as a snow eater. But because of that adiabatic compression, it will get warmer. It will gain a temperature of 5 to 10 degrees Celsius, and that will melt the snow in that area. Similar in the region of Switzerland, around the Alps, you have the Föhn, right, which also melts the snow in that area. So that is basically the case of adiabatic process. Can advection process also initiate from this? See, Anjan, your question is that can advection process also initiate from this? Generally, advection is a process which is initiated due to temperature variation. It is that process of advection in itself which pushes. This is also a horizontal movement of air. Okay, the horizontal movement of air is actually pushing the air above the mountains. Okay, so advection process is eventually going to lead to various different circumstances. Advection process is initiated because of the pressure differences, high pressure, low pressure conditions in different areas. Warmer air rises up. We are hearing this from childhood. Sadly, not many of us have paid heed to what was said in our childhood days. If that would have been the case, we would have been in a much better position. How does air move upwards of mountains against the gravitational force? Very good. So here, let's suppose we consider the region of the Himalayas. Let's suppose you consider the Indian region. Okay. Let's suppose here you have the Himalayas. So if the winds from this area of Bay of Bengal, they come through. Now, the winds are getting pushed through this area. So will they rise up the Himalayas, or will that be the case that they will say that it is a mountain, I won't rise up? So as long as they are getting pushed, from here, they will be forced to rise up, and they will be forced to fall down as well. Unless until the mountain is very tall, still they will rise up. So if there is no, it is not the case that the wind in this place itself, it is not the case that air in this place itself, it today decided that today morning I will wake up early and I will climb the mountain. No. Unless and until there is a movement of air like this, there is nothing which is going to push it upwards. Okay. Now we come to the structure of atmosphere. Now, atmosphere overall, based on the factors of temperature, based on the factors of various concentration, density of air, its different properties, it is divided into different layers. It is not something which is common near the ground surface, is something which is common even to the upper extent of the atmosphere. There is a variation. So the air, based upon the temperature, based upon the properties, is divided into various different layers. The atmosphere, rather, is divided into various different layers. The layer closest to the ground surface, or the layer hugging the ground surface, that is what is known as the troposphere. Above it, you have the stratosphere. Above it, you have the mesosphere, the thermosphere. Eventually, it disappears into the outer space in the form of exosphere. Now, you will observe that the temperature varies. In the troposphere, the temperature near the ground surface, whatever the temperature near the ground surface is, in the troposphere, the temperature reduces with height. The temperature tends to reduce with height here. To the top of troposphere, by the time we go to the top of troposphere, the temperature is in the range of minus 60, minus 70, minus 80 degrees Celsius sometimes. The end of troposphere is marked by a layer that is just like the discontinuities that we have studied in geomorphology, just like that. The region which marks the end of troposphere, that is tropopause. So here, the temperature is almost consistent for a duration, and then in stratosphere, the temperature starts to increase. So at the bottom of the stratosphere, the temperature is zero, almost minus 60, minus 80, whatever it is. At the bottom of the stratosphere, the temperature is low. But as you move higher up, the temperature tends to increase. It increases up till around 0 degrees Celsius by the time that you reach the elevation of around 40, 50 kilometers above the ground surface. That is where the temperature again reaches 0 degrees Celsius almost. Again, as you move higher up, there is that stratopause, the end of stratosphere. And again, after that, there is a reduction in the mesosphere. It reduces up to almost minus 100 degrees Celsius by the time that you reach a height of around 100 kilometers. And again, it tends to increase. So there is that continuous variation in terms of temperature in various different layers. So let us study the various different layers. Let us try to understand the features of the various different layers. So starting with, first of all, the case of troposphere. Now, troposphere is the layer of air closest to the ground surface, sticking and hugging the ground surface. That is the troposphere. Okay, so here basically it contains 80% of the mass, all the water vapor, dust particles restricted in the region of troposphere. It is in this region of troposphere where you will have the maximum density, maximum amongst the maximum mass of the atmosphere is going to be concentrated in troposphere. Why? Because of the same elephant in the room, that is gravity. The force of gravity attracts everything closer to the surface. That is why in the region of troposphere, you have such great amount of concentration, right? Now, the height of troposphere is not fixed. The height of troposphere is greater in the region around the lower latitudes, that is equator. Okay, so from now onwards, another common thing that we are going to use extensively is the fact of lower latitude and higher latitudes. Don't get confused in this. Higher latitudes. Many of you get confused in this. That is why. Region around equator. Okay, and tropics. Region around of temperate and polar areas. So what does that mean? Temperate, tropic, polar, are we aware of this? So if this is the planet, you have the Tropic of Cancer. Those of you who are not aware, kindly become aware. So you have the Tropic of Cancer, Tropic of Capricorn, this is known as the region of the tropics. Okay, this is your region of equator. Then, between the Arctic Circle and the tropics, this is your temperate area, where you have moderate temperatures. And this is your polar area. Okay, right? So, generally, when we say the tropics, we mean this area. Generally, when we say tropics, around the region of the Tropic of Cancer or Capricorn, that is referred to as the tropics under general circumstances. Okay, so please don't be confused by that. Now, coming to the region of troposphere, troposphere basically in the lower latitude, you will find that the height is greater. In the region of the lower latitude, the height of the troposphere is significantly greater here. Okay, that is roughly around 30 degrees north and south of equator. The height is roughly around 15 to 18 kilometers above the ground surface. That is the height of the troposphere. But in the polar regions, the height reduces to roughly around 8 to 10 kilometers. There is a significant reduction in terms of height. So there is that variation in terms of the height of troposphere. Why is that the case? So there are two factors associated. The first factor which is associated here is that I hope we are aware that convection current has got a rising column and a sinking column. Whenever you talk about a convection current, this is the case of a convection current, right? This is the nature of a convection current. Now, in the region of the tropics or the lower latitude, there is always a greater amount of heat received as compared to the polar areas. Polar areas are always colder, right? So, in the lower latitude, there is a significant amount of heat received. So, there is a convection current or a rising air column is mostly to be found in the lower latitudes. So, rising air column in the lower latitudes pushes the height of troposphere. Troposphere upwards. Now, in the polar area, colder conditions, so you have the generally the sinking arm of the convection current. Polar areas, regions, due to cold conditions experience the sinking air column. They experience a kind of a sinking air column. And that sinking air column means reduced height of troposphere. Significantly reduced height of the region of troposphere. So that is the case of troposphere. Now there is another reason here. Now we know that anything which gets heated up tends to have an expansive shape. Anything which gets heated. So it will tend to expand. Anything which gets cooled down will tend to compress. Okay. Anything which gets heated will tend to expand. Anything which is very cold will tend to compress. So in the polar areas, the temperature is so low that air, as not as individual parcels, but air as an entire state of matter also becomes cold, shrinks in volume. In the region of the hotter areas, the air as the entire state of matter gets heated, tends to expand. So that is why there is that consistent expansion and compression associated with this. Okay. So this is also going to experience a kind of a seasonal variation, where in summer seasons, generally, you will observe that in the northern hemisphere, the height of the troposphere varies a bit, and in winter condition the height of the troposphere reduces a bit. So that also tends to happen. This is not always fixed. It is not the case that if I have mentioned here 15 kilometers, then the height will only be 15 kilometers. Sometimes it can be 14 and a half, sometimes it can be 15 and a half. It tends to vary as well. Okay. Now tropopause, we will come to it in a brief moment of time. Before that, we take a look at the region of stratosphere. But stratosphere, coming to the region of stratosphere, before that, the question that you have asked is that why the air rises and sinks? Why is it that the air will rise up? And why is it that the air will sink? Let us understand that first. Basically, let's suppose the air parcel has, yes, Sushmit, absolutely correct. It is the same reason as the case of the mantle convection. So here, let's suppose the air parcel has gotten heated up. It is in the lower latitude. It has gotten heated up. Now, earlier, if the air was like having these particles within it, GIB, you had also said that we have heard from childhood days that hot air rises up, right? See, that's what I told you. Not many of us have heard it from our childhood days. So here, let's suppose this gets heated up. When it will get heated up, the particles will gain some energy. Heat is, after all, a form of energy. The particles will gain some energy. Can you think of a scenario where some of the particles will escape the system because they have gained energy? Can we think about a scenario where some of the particles have escaped the system? Krishika, Megha, let me know. Can we think of a scenario where some of the portions of the air particles have escaped the system? So, a heated air becomes lighter than its surrounding, isn't it? Because the particles have escaped the system, so that heated air becomes lighter than the surrounding. So, if that heated air becomes lighter than the surrounding, it will rise. It will continue to rise. Why? Because it is lighter. Let's suppose it has risen up to this region. It is still hotter than the surrounding. Means what? More energy, lesser number of particles in this. Means it is still lighter, still rise up. So that is why heated air tends to rise up. is lighter and tends to rise up. Are we okay with this? Yes? Now, why does it come down? Let's suppose in a region we have a colder air, very cold. Cold means when we say something is cold, can we say that you have extracted heat energy out of it? That is why it has become cold. So can we say that you have taken out energy from it? That is why it has become cold. So when you take out energy from something, what will happen? More number of particles will come closer to each other because they don't have that energy anymore. They will come closer to each other. So when more number of particles are closer to each other because they don't have energy, can we say that colder air will have more particles as compared to the surrounding? So colder air is heavier than the surrounding, is heavier than the surrounding. Can we say that? Maybe its temperature here is minus 30 degrees Celsius. Now it is heavier than the surrounding, it will fall. Aided by gravity, it will fall. It will reach the ground surface, maybe minus 25 degrees Celsius is the temperature here. Right? So colder air, because it is heavier than the surrounding, tends to sink. Is that understood now? Why the air will rise up, why the air will sink down? Yes? Okay. Now, coming to the portion of stratosphere. Now, what is this stratosphere? Stratosphere is a layer immediately above the region of troposphere. Now, here one important factor that basically we have talked about in troposphere is the fact that because the lower layers were warmer as compared to the upper layers, you had the rise and the sinking of air. Only when the lower layers, if I can concentrate back upon it, only because the lower layers were warmer, here the temperature at A is higher as compared to the temperature of B. That is why the air here will be lighter and it will tend to rise up. So positive lapse rate, whenever there is a positive lapse rate, means with height as the temperature reduces, with height as you have the colder conditions which are prevalent, means what? It means that basically you have the heavier air above, lighter air below, hotter temperature below, colder temperature above, colder temperature, heavier air, lighter temperature, warmer temperature, lighter air. So the lighter air will tend to rise, colder air will tend to fall. So that is why in the case of a positive lapse rate, can we come to a conclusion that there will be strong vertical movement of air? Can we come to the conclusion? Yes? That whenever you have a positive lapse rate, there will be a strong vertical movement of air. So here you have strong rise and fall of air parcel. Now imagine a scenario where the temperature at A is 20 degrees Celsius, temperature at B is 50 degrees Celsius. Will this air ever enter into the region of B? Imagine that. Will this portion of air ever enter into the region of B? No. Why? Because the air in this area will be lighter, furthermore lighter as compared to A. Lighter things will always stay above, heavier things will come down. So always that is the case, that wherever you have a condition where, let's suppose at a height you have minus 20 degrees Celsius, here you have 30 degrees Celsius, this will be heavier air. Here you will have heavier air, and here you will have lighter air. So lighter air will always tend to rise up, heavier air will always tend to fall below. Okay, that is the case of the movement. That is why in the region of troposphere you have a very strong vertical movement of air. However, when we come to the stratosphere, in the region of stratosphere you have a thick layer of ozone molecules. In the region of stratosphere you have a substantially thick layer of ozone molecules, what is also known as ozonosphere. Ozone basically is again made up of atoms of oxygen, but it is O3, not the O2 that we breathe in. So this ozone is very vital in order to protect us from the ultraviolet rays of the sun. So the ultraviolet rays of the sun, when the ultraviolet rays of the sun, they fall upon this ozone layer, some part of it is dissipated and absorbed by the ozone layer in itself. Some part of that ultraviolet rays is absorbed by this ozone layer in itself. Some part of it is reflected back. Significant portion of the UV rays are reflected back. So this ozone layer protects the ground surface from the ultraviolet rays of the sun. Okay. Now, why that ozone depletion, formation of ozone, etc., everything you will study in the portion of environment and ecology. Now, here, that is the purpose, or that is the functionality of the ozone layer, that it does absorb and re-radiate back into the space the ultraviolet rays of the sun. So, if it is absorbing significant amount of ultraviolet rays of the sun, what will happen to the temperature here? In this entirety of the area, what will happen to the temperature? All the ultraviolet rays are absorbed here. So because of that absorption, temperature increases. Why does the temperature increase? Due to absorption of UV rays. So think about it. By the time that you reach the top of troposphere here, the temperature is already around minus 60, minus 70 degrees Celsius. But then in stratosphere, you have the ozone layer. So that is when in the region of the stratosphere, that particular ozone layer will lead to rise in temperature. So the temperature increases. As you move away from the troposphere, the temperature tends to increase. So this is where you will have a negative lapse rate which is observed. Negative lapse rate is observed. Okay. Now, when this negative lapse rate is observed, means the temperature is higher at a greater height, temperature is lower at a lesser height. So obviously here you don't have much of a vertical motion of the air. So here, because of the negative lapse rate, very weak to negligible vertical movements of air is observed. Very weak to negligible. Okay? Very weak to almost negligible vertical movement of air will be observed in this case. Okay? Now, this is one of the reasons. So, if there is no vertical movement of air, can we say that the air in comparison to the troposphere, the air is much more stable in stratosphere as compared to troposphere? Because in troposphere you will have warmer air which will tend to rise up, colder air which will tend to sink down, but in stratosphere you will have a much more stable condition. Can we say that? Yes. This is the reason why the larger airplanes, for example, the intercontinental, the air traffic where you have larger airplanes in use, for example, let's suppose the A380s, the Airbus A380s, or the Boeing 747s, the large commercial jetliners, they don't like that vertical movement of air because that vertical movement of air causes a lot of turbulence. That is why these larger jetliners, they move in the region of the stratosphere. The smaller planes, for example, the smaller ones that you use to move from, let's suppose, Delhi to Bombay, Delhi to Mumbai, or Delhi to, let's suppose, Bangalore, Kolkata, Chennai, etc., the smaller planes for the domestic travel, they will fly in the upper regions of troposphere itself. But the larger ones, they don't want to get entangled with so much amount of vertical movement. They want stability. They use the region of stratosphere. Okay, right? So, meteorite is burning in this layer? No. Meteorite is burning in mesosphere. So that is where we'll end the session here today. We meet again tomorrow where we'll continue with this discussion further. Okay. And till that, Shruti, minus temp indicates a decrease, minus negative temperature, minus 10, minus 5, minus 10, minus 15 degrees Celsius, a decrease in temperature. Okay. That is where we'll restrict the session. Till we meet again tomorrow, do take care of yourself. Goodbye. Thank you. After stratosphere, we'll discuss tomorrow.